Everyone, I am about your PhD student at so this is my job, which I look at what market-based mechanism to crop residue when as PM2.5 pollution is alarmingly high in low and middle income countries. So World Health Organization recommended that the level of PM2.5 pollution should not exceed 5 micrograms per cubic meter. So while the developed country can maintain the level of PM2.5 below 5 micrograms per cubic meter, the level of PM2.5 pollution in low and middle income countries is very at certain time of the year, crop residue burning is a significant season that contributed to PM2.5 pollution. So this figure shows us that when there's an increase in the total of agricultural fire, there's a significant increase in the level of PM2.5 pollution. So why do farmers burn their crop residue? There has been an increasing demand for global food production. So from growing one crop per year, farmers started growing 2 crops per year. And they have very limited time to manage their crop residue between the 2 crops. So when we look at the farming calendar, the first crop is from June to mid-December. The second crop, farmer cultivate the second crop in January, early January. So they have like very limited time to manage their crop residue. Because of the structural transformation, workers move out of the agriculture sector, and that also compel farmers to use labor-saving but polluting technologies such as fire. So when we look at the employment by sector, the employment in the agriculture sector has been decreased. When social costs are not internalized, farmers who face higher private costs than the private benefit would burn their residue, leading to the underselling of residue in the market and overburning of residue. When we look at the cost and benefit analysis, so the cost of the private cost is higher than the private benefit. Among the private costs, the cost of the technology is the most expensive. So I conducted a randomized experiment to test whether incentive to power rent cost for the technology, the compressing technology, can reduce crop residue burning and increase access to the biogas market. And I find that the capital rental subsidy reduces crop residue burning, and crop residue burning is driven by financial constraint. And I also find that crop residue burning also decreases among respondent labor, indicating this indicating that this green technology generates significant spillover effect within the village. So this paper contributes to 3 main literature. The first literature is the literature on market access. The existing literature on market access focus on the market access constraint for traditional crops such as rice, maize, and coffee. So pushing forward the existing knowledge frontier, my study focused on the byproduct of agricultural production, that is crop residue, and attempt to address agricultural waste market failure that produce environmental pollution by connecting farmer to the biogas market for their crop residue. And the second literature, is related to the literatures on technological solution for environmental externality. So the existing study focused entirely on technological solution, but my study is unique because I combine the technological solution with market access in order to address crop residue burning. And the literature is that we also have a very small literature that look at the impact, that look at the effects of incentive on reducing crop residue burning. For example, like Kelsey Jack and Rohini. Wendy has a paper in India that look at the payment for ecosystem on reducing crop residue burning. Why their study focused on the payment for ecosystem? My study focused on, I provide the first evidence demonstrating that the market-based solution reduces crop residue burning.
So the mechanism is very different relative to that setting, but can you sort of benchmark the price responsiveness that you're going to estimate here? Are there reasons we should think of different, that those should be different, or is that something you're able to compare it to?
I am to the payment for ecosystems. I will show like the market-based solution is lower, the cost of the market-based solution is lower than the payment for ecosystem regulators.
Sure. Okay.
This is just a overview for my presentation. So I focus on rice sector in Thailand. Why? Because Thailand is the second largest exporter of rice in the world. And 13 million farmers are employed in the agriculture sector. And Thailand produces 42 million tons of crop residue, and 70% are just burned. That lead to a loss of potential electricity generation of over 3,800 megawatt annually. So we can see like the rice is cultivated across Thailand. So rice residue, this is the rice residue burning in Thailand. So if you have been to country in South and Southeast Asia, like India, Pakistan, Thailand, and Myanmar, you may notice like during the burning season, you may notice that the air pollution level is very high. So this is the agriculture fire. So it's everywhere in Thailand. Farmer just burnt their field everywhere in Thailand. And this is the PM2.5 pollution during the burning season. So green is the WHO acceptance level, yellow is the Thailand acceptance levels, and then red is not acceptable for Thailand and WHO. So I conducted a randomized experiment. So for this experiment, I work with one of the largest biogas power plants in Thailand, and also capital rental farm and the local university, one of the largest local university in Northeast Thailand that work on agriculture. So I only have like two groups. One is the capital rental subsidy group, another one is the country group. So the capital rental subsidy group, the treatment group, received full capital rental subsidy to rent the technology from the capital rental farm. And the control group did not receive anything. So I'm targeting farmer who cultivate less than 2.4 hectares of farmland because 70%, most of the farmers in Thailand are small scale farmers. And I distributed voucher to treated farmers in, and this is the compression technology. So, oh, sorry. This is the compression technology. So when this technology moves, it collects all the agricultural waste on the ground, compress them, make them easier to sell them in the market.
Can you just give us some sense of what that number is in terms of share of daily revenues or something? How large is this subsidy?
So this can I get back to your question on that? Because I will cover it in the next slide. So this is the subsidy, this is the voucher. So the yellow one, the yellow logo is just only the logo of the local university for credibility. And so the voucher is conditional on farmers selling their crop residue in the market. So the yes. So like for the sampling, I use the data, administrative data from the Ministry of Nature, administrative data on fire from the Ministry of Natural Resources and Environment. And using that data set, I selected the province that has the highest agricultural fire for the past 20 years. So using the same data set, I selected 300 villages from the 3 districts that have the highest agriculture fire. And the second step is phone screening. So villages are eligible if they have at least 30 households that burn rice residues and also cultivate 2.4 hectares of farmland. So that left me with 64 villages. And then I randomly selected 16 households in each village, make up the total sample of 1,024. And I have like 512 farmers in the treated group and 512 farmers in the control group. So this is my study area. Green spot are treated villages, and brown spot are control villages, and white spot are phone screening villages. So it was difficult to implement this experiment in 2023 because in March and April, when I did the baseline survey, Thailand was hit by extreme heat wave that significantly affected production of rice and rice residue. And in November, when I rolled out my intervention, it was not supposed to rain, but it rained so heavily, flooding so many fields, including some field in my sample. So this is I did a baseline survey in March and April 2023. During that time, I measure my outcome at the plot level. So I also map the plot of farmland. How did I map the plot of farmland? I did not have to use the GPS survey to walk around the plot of farmland like the study in India. But I was lucky that I have access to the administrative data on all the plot of Thailand across all the plot of farmland across Thailand. So this one. And then so in Thailand, farmers have what they call like green book. This green book is a farm registration book which has important information about the plot identification number and also like the type of crop farmer cultivate on the specific plot and the productions. And so I just get the plot ID from farmers in the baseline. Yeah. And I did the LI survey after in January 2024. And during that time, I also get neighbors, a respondent neighbor. In neighbor, they have like 1 to 5 neighbors. So I also get the plot ID of neighbors. And in total, I have over 4,000 plot in my study. So these are some of the plot in my study. I have like treated plot, control plot, and neighbor plot. Yeah, the attrition is very, very low. And so the main outcome of interest is the crop residue burning. So I am interested in whether a plot is burned or not burned. So to do so, I verify all the field after the intervention, after the burning season in January 2024. I also use high-resolution satellite imagery, such Planescope. Planescope has 3-meter resolution, capture data as higher frequency level, so is it less likely to miss burning event. I also use alternative satellite imagery, that is the Sentinel-2, to validate my main finding. And market access data come from the administrative data from biogas market. And I also have like the production of crop residue and self-reported agricultural income from survey. This is just my estimation strategy. P1 is the intent to treat. This is my main finding. I find that so like for the column 1 and column 3, look at the full sample. And column 4 to 6, look at the non-flooded sample because when I roll out the intervention, it rained so heavily, flooding so many fields, including some field in my sample. So I restrict my sample to non-flooded field from column 4 to 6. So in column 1, I find that the treatment reduced crop residual burning by 0.103 percentage point. And then when I here in the result remain consistent when I use the alternative data set from Sentinel-2 satellite imagery and ground field verification data. And I find that the 3 data sources, Planescope, Sentinel-2, and ground field verifications are very similar. So the crop burning measure from Planescope performed exceptionally well compared to crop burning measure from Sentinel-2 satellite imagery and ground field verification. So when I look at non-flooded sample, my estimated effect is a bit higher. This is just a visualization for the treatment effect relative to control from 3 data sources, Sentinel-2, Planescope, and ground field verification.
Sorry, just a clarification. Is the outcome from 0 to 1 or from 0 to 100?
So 0 to 100. And the classification threshold is 75%, but I also show that the estimated effect is not sensitive to the crop burning threshold. Yes. So what are the mechanisms? How does the technology, the subsidy, reduce crop residual burnings? And then I find that the treatment, so this market access, the market access data come from the biogas market. And I find that the treatment increases market access and also production of residues and self-reported agricultural income. So if farmers do not burn their crop residue, they would produce crop residue. If they sell them in the market, then they would, their income will improve, increase.
So how big a problem is if you applied your treatment effects to crop burning over a larger area?
Yeah.
How big a contribution to it? We know about the PM 2.5 emissions.
Yeah.
Is that a big source of emissions of burning the,
Yes, during the burning seasons, yeah.
like Prakash had a number, right? It's like 11% or something in terms of emissions. What would, like, CO2 emissions, how much would crop burning contribute?
CO2, I did not look at the CO2 emission, but then I will look at that, so yeah.
But it's
Yeah.
pretty widespread, it's noticeable across.
Yes, yeah. And the reduction in PM 2.5 emission, yes. I look at that.
So could you say a second what do you mean by market access?
Like market access is equal to 1 if farmers sell their crop residue in the biogas market.
So this is a bundled treatment, right? There's a technology and market access. And are you able to say something separately about the two?
I am afraid no, because of the limited budget, I have to like combine all the interventions, like bundle intervention. But that is the plan for the next step. The government is also interested in scaling up the intervention, and that also enable me to look at like different intervention on which one is like the most effective.
But if you don't have your treatment, are you still able to sell to the biogas if you wanted to?
They can say, yeah.
But no one does.
Yes, no one does. Like especially for rice farmer, because it's not profitable for them. I find that the crop residue. So in the first column, I look at high financial constraint, and the second column, I look at high distance constraint. It's the distance from farm to the biogas market. And in the third column, I look at high information constraint. It's based on like two types of information about the negative consequences of crop residue burning, and information about where to run the technology. And I find that the effects are concentrated among farmers who have high financial constraint at baseline, and then also who have high distance constraint at baseline. And the results are also robust to the alternative data set from Sentinel-2 satellites and ground field verification data. And here I find, I also find like, because in the NI survey, I ask respondents, I also collect the neighbors ID. And farmer, they have like 5 neighbors. So like I asked them like in the NI, among their neighbor, who is your main neighbor? They talk to the most about everything, including agriculture. So that is the main neighbor plot. And then the second column is all neighbor plot, because like some of the neighbor also receive the treatment. And then in the third column, I look at like plot neighbor who did not receive subsidy. And I find that the treatment also reduced crop residual burning amongst like main neighbor, all neighbors, and neighbor who did not receive the treatment. And the results are also robust to alternative data set from Sentinel-2.
Can you break down a bit why that might be? So if they're not receiving the subsidy, presumably the fact that you've got the machine there means that access to it is still cheaper, or is there some information thing that they realise that the air quality is better? Can you see whether or not they are using the technology, even if not subsidised, to do so?
Yeah, I'm afraid I did not have a chance to look at the transmission mechanism for the spillover effect, because in the NI survey, I could only like ask for the plot ID of the neighbor. I did not survey the neighbors. So but like for the next step, I will.
That's anecdotally, even the target treatment plot themselves, they may be able to answer, did your neighbours also make use of the technology while?
Yeah. My sense is that it's because of the economy of scale. When the technology is innovation, it's easier for others to use the same technology.
There is also, I believe, these things that if you're using it over a larger area, it's more efficient. Anyway, you could sort of use the spatial distribution.
Yeah. And I look at the cost effectiveness, so like the damage from PM2.5 pollution from ripe field burning, so the cost per unburned acre is $40 per acres, and the damages is over 1,500 per acre. So the cost of the damage from PM2.5 pollution from ripe field burning is like much higher than the per acre cost of reducing burning. And just a few.
Can I ask a question on
Yes.
this? Sorry, circle back to my earlier question on this.
Yes.
This is obviously a really key magnitude point. The point I was trying to get at was how large the subsidy is relative to income or some measure of how accessible this sort of a cost might be in the absence of this intervention. But if one could think of a kind of broader government or other intervention, is this something that's very, very expensive relative to average incomes here? Or could villages pull together and this is something that's accessible?
Yes, so like for the like so in my sample, farmer made around like over $50 from selling their crop residual. But then like the profit was much lower because of the heat wave in 2022 that significantly affected production of rye and rye residual. But in normal year, they for farmer who have like 2.4 hectares of farmland, they should be able to make over $100. But like for $50 is around like 5% of farmers' agriculture incomes.
So are the bigger farmers, if you have more land, presumably you're richer and more likely to develop?
Yes, yes. I only targeted for this experiment. I only targeted smallholder farmer.
Okay.
So I did not look at large scale farmer. But then, like when I met with the large scale farmer, they told me that no, why did you exclude art from this experiment? And so yeah, maybe that is the issue I will need to address.
Can the small farmers pull their resources?
Yeah. Yes. So a few points to conclude my presentations. I find that the subsidy, the capital rental subsidy, reduces crop residual burning and increased market access. And also effects are concentrated among farmers who have high financial constraint and then who have high distance constraint at baseline, constraint to the market at baseline. And then I also find that the treatment reduces crop residual burning among respondent neighbor. Indicating that improving access to this green technology can improve widespread adoption of sustainable agriculture practices. And the cost is much lower than the potential burning damages. So seeing the government is interested for the next step, the government is interested in scaling up the intervention. So I am currently working with them to conduct a large scale experiment because from my study, I find like the short-term effects and it raised a critical question about like the incentive structure that would be needed to reduce crop residue burning and air pollution in the long term. And so I'm working with the government on the large scale RCT. Thank you.
We have a few more minutes for questions. Are there any countries that implemented this typical subsidy?
Yeah.
The first question. The second question is, are these technologies is quite common in Thailand, particularly in the village?
Yeah, they just started introducing this technology in Thailand. That's why like the cost is very high. And the first question is,
are there any countries that have implemented this typical subsidy, especially for crop burning in other countries?
other company, no, I'm not aware of that, but like there's one study, Michael Greenstone's, and he has a project in Pakistan. He is looking at another technology. So that technology is different from my technology. So for the one Michael Greenstone is testing, so that technology integrate all the agricultural waste onto the grounds. And but then like I learned that technology is much more expensive than my technology, because I need to make sure that all the agricultural waste are thoroughly shredded into the into the ground. So we have to use at least like 2 rounds of machine. So it's more expensive than the technology I'm testing in Thailand.
So why is the neighbor plot the right counterfactual? Why can't you take a random plot in the same village and just measure its outcome? Because you have the plot ID
Yes,
and.
yes. So in the NI survey, But I should be able to do that because I have access to administrative data on all the plot of farmland in Thailand. I should be able to look at that, yes. Thank you.